So in this example we're going to look at how to write 4 cos x plus 3 sin x in the form k cos x minus alpha, where alpha is between 0 and 360 degrees. So we've got a cosine wave with an amplitude of 4 added to a sine wave with an amplitude of 3. We need to generate this new format where k is the amplitude and alpha is the phase angle here. Now the first thing you always do here is use the addition formula to multiply this out. Now you can look at the formula sheet, but I know from experience it's cos, cos, sin, sin, and the sign changes from a subtract to a plus. So we're going to have k cos x cos alpha plus sin x sin alpha. I'm then going to multiply through by k, and I'm going to rewrite the cos alpha at the front. You'll see why in a second. So and then I'm going to put the sin alpha at the front as well. So k cos alpha cos x plus k sin alpha sin x. So these two things are equal. And what we want to do next is compare coefficients. What I mean by that is we want to compare this here, the value in front of cos x, to the value up here in front of cos x. And we can see that these two things are equal to each other. So k cos alpha is really the same as number 4. So we'll write that here. And then we can go on to simplify it further and say cos alpha is equal to 4 divided by k. The next thing I'm going to do is I'm going to look at the other side here. I'm going to look at the k sin alpha, and that's the coefficient of sin x here. And I'll look up here and see that's a 3. Now, we can really just say that k sin alpha is equal to 3 because these are the same with the parts in front of the sin x and the coefficients. So now that I've done that, I can say that sin alpha is equal to 3 over k. I'm now going to use these parts here, and I'm going to use them and this to look at a triangle, a right angle triangle. Now I already know that cos alpha is equal to adjacent over hypotenuse from my trigs work. So that's adjacent, if you like, over hypotenuse. So if I was looking at a right angle triangle, I should be able to label the right angle triangle where 4 is the adjacent and k is the hypotenuse. So here's a right angle triangle, alpha here, k and 4. Now the same idea, I know from my work that sin alpha is equal to opposite over hypotenuse. So k is the hypotenuse as here, and the opposite side's the one opposite angle, so that's this one. So that will be a 3. Now that I've got a right angle triangle with two sides, I can use Pythagoras to work out k, which is that first bit there, the amplitude of the new wave. So I'm going to do my Pythagoras in one line. I'm going to do 3 squared plus 4 squared and square root it. Now, I already know that that's a 3, 4, 5 triangle from my Pythagorean triple, but you could square the 3 and square the 4, get 25, square root it, and get 5 by Pythagoras. And that's the first task, to get the amplitude of the new wave. So the amplitude of the new wave is 5. The next task is to work out the angle. This angle here, the angle that the cosine wave's been shifted. So let's have a look at that. Now, I'm going to repeat this down below just because it's going to be off the screen. I'm not doing anything new here. I'm just rewriting this part down here. So there we have it. We worked that out up top. So what we have to do is we have to work out this angle, and we have to work out what quadrant it's in. And the easiest way to work out what quadrant it's in is we want to look at cos alpha and decide if it's positive or negative. Now this is obviously positive because you've got a plus 4 over a plus k, so positive. I'm then going to tick where the cosine wave is positive, and that's here and here. I then look at our sine alpha, and we see that that's also positive. And I want to tick where sine is positive, and sine is positive here and here. So the shifted angle is in the first quadrant. You always look for the quadrant with the 2 ticks in it. So in this case, it's the first quadrant that we'll find our shift angle, or phase angle. I then have to work out what the base angle is, or the relative acute angle. So I use my triangle with 3 and 4, and I'll do a bit of trigonometry. I know that 3 over 4 is opposite over adjacent, which is the tan of the angle alpha. So tan is equal to 3 over 4, tan of alpha. I then work out my acute angle, inverse tan that, and get 36.9. And this is in the first quadrant, so I leave it as 36.9. Now you can also say that tan is equal to sine over cos. And if you look up here, sine over cos, the k's will cancel and you get 3 over 4, so that also works. So then I just complete what I was asked to do. I was asked to rewrite this in the form k cos x minus alpha. I've worked out my alpha and I've worked out my k. So I'm going to write those values in. I've got 5 cos x minus 36.9, and I've finished what I started doing.